I'm Jacob Culp with Kentucky Division of Water in the Water Quality Branch and Monitoring Section, and I've got with me today David Smith, who's also in the Monitoring Section. He's a macroinvertebrate expert, and we're here at the South Fork Elkhorn Creek in Frankfort, Kentucky, and we're going to do some biological and water chemistry sampling and sort of overview what we do in a typical site visit. So I'm going to start off and do some water chemistry and physical chemical measurements. First, I want to bring in Sarah Andre here, and she's also in the monitoring section. She's wearing some cool gear. This is our backpack electrofisher, and we use this to slightly stun fish to do some collection so we can survey the fish populations. It's basically a battery-powered generator with an anode and a cathode. And Sarah controls the electricity and basically stuns the fish so we can collect them. We're not going to use this today, but did want to demonstrate this is something we usually use when we're in the field. We're going to do some seining and collect some macroinvertebrates as well. So I'll go ahead and start doing the water chemistry, and David and Sarah will do some macroinvertebrate collections. Okay, I'm going to start by setting up the YSI. This is our water chemistry meter. I'll show it off here in a second as soon as I get it out. And this tells us parameters like dissolved oxygen, pH, conductivity, and temperature. So I place this in the stream before I begin water chemistry sampling with the bottles. You usually want to put this in fairly swift moving water. You don't want to put it in a dead, slow area. So I'll take it out here and place it right here, and it'll start measuring. We always use nitrile or latex gloves so we don't contaminate the sample. So we collect a lot of different water chemistry parameters. We use 4 bottles, if I can get the gloves on. There we go. So we have a bulk container, and this collects things like dissolved solids, chlorides, and fluorides. We have nutrients, which collects phosphorus, nitrates, nitrites. We have a metals bottle, and this collects metals that we have water quality standards for, like iron, lead, nickel, cadmium. There's a lot of different metals in here. Some of them we have standards for. And then we also have an alkalinity bottle, which is like acidity and alkalinity. So when we collect these, we try to go to an area that's flowing, good flow. We want to stand up downstream of the flow so we're not going to get any debris into the bottle. And we fill it up and do a triple rinse on it. So rinse it, rinse it, and then rinse once more. And that's when will be our bulk sample. Needs to be mostly full. After this gets placed into a cooler and takes to our environmental services branch for analysis. We do the same thing with all the rest of the bottles. Rinse 3 times. And then collect your sample. After we collect all 4 bottles, we add preservatives to the samples. We use nitric and sulfuric acid. So each one of these, the metals and the nutrients, gets a fixative added to those. So we pour this into the sample, shake it up, and then all of these get iced. So our YSI, our chemical parameters here, physical chemical parameters. We use these a lot to tell us a quick idea of what's going on with the stream on that day when we're there. We can use parameters like pH and conductivity to give us an idea quickly of what the stream health is. Conductivity varies from region to region, but generally you can look at it and get a pretty good idea of what to expect with that water chemistry and the biological life you may find there. So that's basically the water chemistry in a nutshell. And I will put this up, and I believe David and Sarah are doing some macroinvertebrate collections. I'll kind of tell you a little bit about what they're doing. Okay. So Sarah has a dip net, and she's collecting the multi-habitat, which is kind of the areas where you may find roots and sticks and leaf packs. This is not our quantitative portion, but a qualitative portion of the sample to collect species that don't occur in riffles. And David has been doing, you might have seen him in the background, he's been doing a quantitative riffle kick, which is a 1/4 meter net, and we do 4 of those at every site to give us a meter square of riffle habitat. And that is a semi-quantitative measurement. So I'm guessing now David's got some macroinvertebrates that he's collected that he's going to show and talk a little bit about.
Yeah, so like Jacob said, I've been collecting some macroinvertebrates. I was using that rectangular net, and that's our semi-quantitative sample. So before I show you some of these bugs, what we do is we get our sample and we dump them into these buckets that has a mesh bottom, and that collects all the bugs. And then we preserve these samples and take those back into the lab to identify the insects. So you can see a few things maybe kind of moving around there, but I've got some in a separate tray here. Let's see if we can get the camera on it. So you'll notice, yeah, here's a big old stonefly. We've got some mayflies swimming around in there. We've got some little roly-polies somewhere. There we go. So basically, all these different aquatic insects are indicators of water quality. Each one is, some are more tolerant of pollution. Usually these isopods or the roly-polies. But then things like the stoneflies, the mayflies, and then also caddisflies, those are not very tolerant of pollution. So those are important indicators, things that we look at. Basically, all the different kinds of species, they have different scores, just basically points that we give them for how tolerant or not they are, and we can kind of use those points and get an idea of like the total quality for a stream. So that's how we kind of use the insects, how we collect them. I think now, here just shortly, we're going to show you how we collect some of the fish using a seine net.
So, for our multi-habitat sampling, sorry. This is good. Does that work? Okay, so from our multi-habitat sampling, we got a couple of cool things. First thing is these little guys, which are corbicula, that are a tiny clam that's actually an introduced species. So you've maybe seen these if you've been out in a stream. Oftentimes there'll be tons and tons of them, and the shells can really pile up. We're not exactly sure how these interfere with native species yet, but they can be really prolific in some areas. And then, this guy's just for fun. Sometimes we do get crayfish. We don't do any targeted sampling for them, but it's kind of just as we're going out and doing our semi-quantitative sampling. If you see one, you'll kind of grab it, and we'll bring these guys back. And just like with the other invertebrates, we use them as a measure of stream health. So we'll put this guy back. And I think these guys were wanting me to show some of our fish while they're out there collecting. We already went out earlier so that we could make sure we'd have something to show you guys. All right, so this is a northern hog sucker. These guys are fairly common and they are pretty much herbivores. They live kind of on the bottom of the stream, usually around areas with sort of bigger, looser rocks, and they will kind of scrape the algae off down there. And this is about a medium-sized one. They can get a little bit bigger, but they're not huge fish. All right, so in here we've got a few different species of darters. So there are a lot of different kinds of darters. They're smaller fish that usually live in sort of the more fast-flowing parts of the stream. And just like with everything else, we use these as indicators of stream health. And a lot of these guys, you can see a little bit on this biggest one here is a greenside darter. And when they're in their mating season, the males will actually get really, really colorful. So they can be really beautiful fish. Some of them more than others. Some of these little guys pretty much look like that all year round.
We've collected a golden red horse here, and we've actually collected one other one that's a little bigger. I'll bring it over and show. This is a migratory fish. It's common to see them up around dams this time of year for spawning. So David also has another common species that you see a lot in small to medium-sized streams. That's called a hog sucker.
Gotta kiss it, right?
Yeah, you gotta kiss it. That's good. That's good stuff. Okay. I'm gonna go over here and show you guys the hog sucker we collected earlier. I'll bring it to the camera in just a minute.
So many chins. All right. So I don't know how close we can zoom in on this guy, but I brought him because this is my very favorite small fish, which is the central stone roller. These guys are really cool. Like a lot of the other ones, they'll get some breeding colors, and they actually will grow these little horns on their heads. But something that's cool about them all year round is that they have this little plate on their bottom lip that they use to actually to scrape algae off of rocks, which is really unique adaptation that even a lot of other fish that sort of live on the bottom like that don't have. And this is a pretty big one of these guys, but they're fun.
And this is the same species we collected earlier, golden red horse. You can see the orange fins, actually similar to the stone roller she was showing you. But like I said, this is a common species we find in these mid-sized streams, and they're migratory fish. probably moving up for spawning. We seined him a little bit earlier, so I'm going to place him back in the stream. Should we do one more seine haul?
Sure.
We're going to do one more quick seine haul. Sure, Jot.
All right, one last fish from earlier. This probably to a lot of you looks like a bluegill and is closely related. It's not actually a bluegill, but it's some other kind of sunfish, possibly either a pumpkin seed or a long-eared sunfish. There's several species of those, which even sometimes can hybridize, so they can be a little tricky to ID sometimes when we're sampling. But just wanted to show one more that might look a little bit more familiar to some people watching. If you're a fisherman at all, you've probably seen these.
We might just have to carry this back over. Let's roll it up a little bit and we'll just walk it back across. I don't know how much time we have left. Okay, we're going to be walking through some quick water here. Be safe. Okay, we've gotten a bunch of shiners with this seine haul. A lot of minnow species, and there's also some darters in here. We'll take a quick look at these. Okay. We've got several different species of shiners in here. These are blunt-nosed minnows. Very common. We've also got some spot fin shiners. So these are the blunt-nosed minnows, and you can see that real dark stripe on them and the little spot on the tail of the caudal peduncle. And look at that, that's a nice looking green side darter. It's male, it's got some breeding colors. I'll put this guy in here too, and this last one I put in is a spot fin shiner. This is something we see in another fish that's really common in these medium to large size streams. And you can see on the dorsal fin, there's a little bit of a couple of spots there at the end. But they're a typical minnow shiny fish. So we've collected a few different species here. I think they're releasing the last ones. I'll release these. So at this point, I guess we can talk a little bit about, David, do you want to go out and grab the kick net and you can demonstrate a kick net for the riffle kicks?
Yeah, put one over there. I'll do one.
Okay. So David's going to demonstrate a riffle kick, which is one of our semi-quantitative measures, and we do them in riffles. As I was saying earlier, it's a 1/4 meter area that he'll kick, and he'll collect everything within that 1/4 meter area. We take that back to the lab and identify a percentage of a set number of everything in those riffle kicks, and that gives us a kind of a standard measurement that we can use across all streams. So that's a standard, that net is, like I said, it's a standard 1/4 meter sized. So by kicking everything in the shape of the net in front of it, you get a 1/4 meter kick. And so what he's going to do now is kick through that area where all the cobble and gravel is. If there's any large rocks, you might see him kind of bend over and wipe off some of the large rocks to make sure he's getting all the macroinvertebrates off those. And he'll do this at 4 different locations in the stream. Generally, what we try to do is look for a diversity of habitat. So what we want to do is find riffles that are not all the same. David wouldn't want to do all 4 riffle kicks in that one riffle. He would want to look for a diversity of habitat, so different size and shape riffles with different materials in them gives you a better idea of what's the picture of the entire stream instead of doing it all in one area. So David's just done a typical riffle catch, which we do 4 of. And David, do you want to demonstrate some, or Sarah, demonstrate some multi-habitats? Maybe some root. So Sarah's going to go over to the other bank, and there's some undercut banks over there, and we usually sample, as part of our multi-habitat, we sample undercut banks and roots. It's usually a good place to get macroinvertebrates that are not going to be found in riffle habitat. So this is not quantitative, but it's picking up those extra species that we would not normally find in a quantitative sample. So this just goes into a species diversity or richness of taxa at a site. So she's going to demonstrate real quickly a undercut bank sample. So she's going to thrash there into that undercut bank at the tree root. And usually, man, that must have been good. Usually the kind of macroinvertebrates we find there are, we find a lot of dragonflies and damselflies, macroinvertebrates that cling to the roots of a tree or undercut bank area. And there's a great blue heron. We can also talk a little bit about, at each site we have a RBP form, and this is basically just lets us know everything we need to know about that site. So this, we write down our standard information, the site name, the number, when we were there, basic standard site collection information you would for any site, date and time. We also have some other things on here, like we would look at local watershed features. In a place like this, we may say that there's some residential area, there's also some forest. We kind of use these things when we do our assessments to make an overall assessment of this area of river and the reach in its entirety, and that allows us to get a better picture. All of these things we do. On this form, we look at kind of how much of the habitat is riffle, run, and pool. We kind of try to estimate what percentage of each one, and then on the back we have what we call our assessment data sheet, and basically we go through each one of these parameters, these habitat parameters, and we usually discuss something like the epifaunal substrate or available cover for macroinvertebrates and fish, and we basically give it a score. And the score is a 0 to 20, and a 20 would be as optimal as you can get, and a 0 would be as a concrete lined canal. And so we basically try to judge the score for that for that particular parameter. So each one of these we would go through and we would discuss as a group what we kind of thought about each habitat parameter. We have things like embeddedness, so how embedded is the actual substrate? Is there a lot of silt and sand preventing any aquatic life from using that habitat? We look at the different velocities and depth regimes to make sure it's not all one big pool. For aquatic life, we want to see a variety of habitat, a variety of depths and velocities, slow and fast water, deep holes, shallow riffles. And so we have sediment deposition, where you see areas where sediment's washed up on the banks, piled up in the middle of the stream, and we score each one of these. And then at the end, we give it an overall score for the habitat at that site. And that goes into when these sites are assessed for their aquatic life, that goes into our water chemistry and our biological scores to give us an overall picture of what the aquatic life is and the usage for that site. You have anything to add, David?
I think that's it. So, it's, yeah, I mean, yeah, kind of cleans things up, I guess.
Yeah. I think that covers the basics of what we do. If there's any questions, I'd be glad to answer them. Okay, yeah, so that's it for us today, and thanks for coming out and checking out what Division of Water does and monitoring at the streams. And like I said, I'm Jacob Culp and David Smith and Sarah Andre. Thanks.